Okay, this is the biphasor. We have a lot of information to cover, so I don't know if I can get through it all in one video. The first thing to note is that this is called a biphasor and not a stereo biphasor. And the reason for that is because it doesn't process stereo signals. It sums stereo signals to mono, and it can give stereo information in one of the configurations, specifically the dual stereo mode. But let's talk about what these modes are specifically. So we can route phasor 1 and phasor 2 in different configurations with this routing control. So let's go over serial. We have the stereo signal being summed to mono, and now everything that passes through here is the wet signal. The dry signal is just going straight to the output, of course, without processing. But the process signal is summed to mono. It goes into phasor 1. Phasor 1 has feedback or resonance control, and then that feeds into phasor 2 serially, and that has a resonance control, and then that signal is sent to the left and right output. So serial mode is pretty simple. Phasor 1 going to phasor 2, nothing too crazy. The next mode we have is dual. Now dual mono is the most interesting of the three, in my opinion. We have the signal, of course, summed to mono. That mono sum is going into phasor 1 and phasor 2. Each of those have feedback controls or resonance controls for the, you can think of them as notch filters. Well, I guess they are all pass filters, but they functionally, they act as notches. And then we have these attenuation controls, which are right here. And then that's the signal from phasor 1 and phasor 2 is summed and sent to the left and right outputs. Lastly, we have routing mode dual with output mode stereo. Sum to mono, go into each phasor. We have our attenuation controls, but then phasor 1 is sent to the left channel, phasor 2 is sent to the right channel. This is pretty easy to demonstrate. So right now I am in dual mode. I have my input signal being summed, going to phasor 1 and phasor 2, but then phasor 1 is going to the left channel, phasor 2 is going to the right channel. So if I turn down phasor 2, what am I doing? Let's look at this. This is a stereo spectrum analyzer. You can see the left and right channels individually. So if I turn down phasor 2, which is being sent to my right channel, of course we'll get a signal that is hard panned left if I had my wet all the way up. So now we're only listening to the process signal. Phasor 2 is all the way down. We're only hearing the left channel. I turn up phasor 2. I turn down phasor 1. We're now only hearing the right channel. So let's talk about phasing. Remember when we are listening to just the wet signal, we aren't getting any phase cancellations. The only way we get phase cancellations is when we sum with the original signal. So let's take serial, for example. We have the manual control in each of these phasors. This controls the cutoff position of the notch filters. You can think of it like that. When we're listening to all the way wet, we're causing phasing, but we only get phase cancellations, again, when we sum with the original signal. So basically this does nothing. I can move this around. I can move this one around. We see no change to the noise. We see no cancellations going on. Same thing with dual stereo. I'm not summing with the original signal. Again, only listening to wet. So by moving the manual controls, we get nothing. But dual mode mono is pretty interesting, because think about this. We are summing the signal, so we have a copy of the signal, but then we are summing each copy together. So that means if I have this signal that is then has phase shifting going on, which has the ability to cancel things out with the original signal, when I sum that with the copy that's in phasor 1, I can get cancellations. It of course depends on where the cutoff positions of the phasors are. If they are in the same position, then I get no cancellations. But if they're in different positions, well, first of all, let's put them both in the same position. Again, no cancellations. But if they're in different positions, that means the phase shifts from each phaser can give us cancellations. So we get lots of interesting movement that way. I think dual mode mono is like kind of a sleeper there as far as like cool modes go. So let's take a look at like each phaser individually. I can just turn down one of these channels since, again, with dual mode mono, we have the same signal being summed going out of the left and right channels. By turning down one of the phasers, I'm then only sending one single signal to the left and right channel. And so since it's the same signal going out of both channels, we can just look at one of the channels and we still hear it in stereo. But we are now only looking at phaser 1 right now. So with phaser 1, again, if I move my manual control, we don't hear anything. But if I sum it with the original at 50-50, we do get cancellations. And so this phaser is interesting. It's like having 3 notch filters, and then the manual control is changing the cutoff position of those notch filters. So you can see 1 notch, 2 notch, 3 notch. And know that we also have negative wet. So when I sum with negative wet, all this is doing is it's taking the output of this processing and it's doing a polarity flip. So when we sum that, we actually do get a lot of cancellations, and it ends up sounding almost like a high-pass filter. Like we end up losing a lot of data down here. But yeah, if I had no phasing going on, technically having a negative wet would give us a total cancellation, but because of the phasing causing the phasing cancels the null basically. Yep. So that's pretty interesting. With this LFO section, let's go over this. We have LFO 1 controlling the manual control with this depth parameter here. And so if I turn up LFO depth, we'll see bipolar modulation happening to the cutoff position of these notch filters. Goes up and down. We control the frequency here. It goes up to like 10, 20 hertz. And it's the same thing for phaser 2. Right now, I have the LFOs locked, and I'll explain what that means. That is when LFO 1, the frequency of LFO 1 applies to both LFOs. LFO 1 is still only affecting phaser 1, and LFO 2 is still only affecting phaser 2, but since their frequencies are locked, they almost act like the same LFO, but with LFO 2 offset, we get an offset between the left and right channel. It's probably best demonstrated in stereo mode, and so let's view this in stereo. Let's turn up both phasers, and let's just sum it regularly. We could do negative wet, it doesn't really matter, but as long as we're summing with an original signal, we can see phase cancellations. So with no offset, I am affecting the manual positions equally. You could think if I have at least the same amount of depth. That's the other nice thing. Even with the LFOs like locked, quote unquote, locked together, we do still have independent controls with the manual positions and depth of each LFO on each phaser. But I don't have to have them moving the same way. I could do this phase offset. So you can see I have 80 degrees of offset here. I could have 180 degrees of offset, in which case they'll be when one is moving up, the other will be moving down, and vice versa. I could have one have more depth than the other. I could have one have no depth. I can change the manual positions. But I can also unlock them. It means I don't get to control a phase offset, but I get to control frequency independently between each LFO. So let's say I'm only listening to LFO 1, and I have it traveling at this fast rate. Sorry, I'm only listening to phaser 1, which LFO 1 is acting on. And in mono mode, it's sending the same signal out of both channels. In fact, if we just look at the left channel, it's no different than looking at it in stereo. And then, of course, phaser 2 is going a lot slower. It's being affected by LFO 2. Yeah. And then, last but not least, we do have a source control, which will control the depth of LFO 1 on the manual control via this amount here. And that depth source also affects the depth of LFO 2 on phaser 2. And I guess last but not least, we do have this resonance control. Resonance is pretty interesting. We only have resonance, by the way, in a positive direction. We don't have it in a positive and negative direction like the regular stereo phaser, but that's okay. Let's just listen to phaser 1. And even if we're just listening to only the wet signal, if we give it resonance, it's powerful enough where we can hear the phaser at that point. We don't need to sum with the original signal in order for us to hear the phaser. So that's a good thing to note there. That's everything to do with this unit, and I hope you enjoyed watching it, and I'll see you later.